Hey guys, this is Ron. So in the last video we talked about integers, we talked about floats, we did some logical comparisons. We also talked a little bit about the string object. Now one thing that should become readily apparent as we go through this video is Python is an object-oriented language, meaning it tries to represent things as objects. So for instance, like an apple. An apple has attributes. Those attributes might be color, shape, size, weight, but it also has methods. So I can throw an apple, I can eat an apple, I could, bury an apple. There's all sorts of methods or functions that I can perform on that object. So think of a string as just another one of those objects. So what are some things that you would want to do to a string? Well, I might want to convert its case. Might want to send it to uppercase or lowercase. What are some attributes? Well, the value of that string is an attribute, right? So again, the string is an object, and because it's an object, it has a lot of other things that are built in. So for instance, if I create a variable called a, and I'm going to assign it the value of this is a string, what I will find is that a is of type string, str, and because of that, there are a lot of other things that are built in. So if I do a dir on a, what I will find is that all of this functionality is already built in by the mere fact that it is an object of type string. So what we see is that I can decode a string, encode a string, I can do a find operation within that string, I can replace things within the string, I can convert it to uppercase, I can convert it to lowercase right there. So there's all kinds of different things. I can join it with other things. So again, lots of power built in just because it's an object of type string. So if I do a dir on string, what I'll find is I get the exact same things. When I created my variable, all I had to do was give it some bit of text. Python in the background said, well, you're trying to create a string. So let me create an object. I will call that object a. And because this object is based on the fact that it's a string, you will get access to all of this. And so that gives me a lot of control. So I have a, I can do a.upper, and my methods typically have to have the opening and closing bracket like that. It automatically converts to uppercase. Now it didn't change the value of a, it just displayed it that way. If I wanted to actually change the value, I would have a equals a dot upper. And so now I get this is a string in uppercase. All right, so right off the bat, just by the mere fact that it's a string, I have a lot of control over the text that I place in this thing. So let's do a find operation. So if I needed information about the format that this find method is going to require me to put my stuff in or what it returns, I can do a help on a.find. And so what it's looking for, if I read through this, is in my string, it's going to look for a substring that I give it. Now, I may or may not specify a starting and an end point within this main string, but it's going to look for this, and if it finds it, it's going to return an integer value. And that integer value is the index of where this substring exists within the main string. Now, if it can't find it, it's going to return a -1. So if I quit out of here, I've got this is a string. So I a.find, and I'll do is, and I get the value of 2. So a string, just as in many other programming languages, the index always starts with 0. So this is 0, 1, 2. So it returns 2 because IS was found at position 2. Okay? Now, if I enter something that doesn't exist in there, let's say I did lowercase is, well, that doesn't exist within A because A is uppercase. So it returns a -1. Okay? So that's pretty cool. That enables us to find all sorts of different substrings within the main string. So what else can we do? Well, I invite you to take a look at most of these methods within here. As we go along, we'll find that we'll end up using split quite a bit. We'll end up using strip quite a bit, and then a few other of these to maybe test to see what's inside. Does it contain alphanumeric characters, or is it all alphanumeric characters? Is it all digits? Is it all lowercase? So on and so forth. So again, there's lots of different things that we can do in here, and I invite you to check them out. I will move on though to the len function. So len, I can pass it some variable, and in the case of a string, it's going to tell me the number of characters within that string. So this contains 16 characters to include the spaces, right? Now if I pass it another data type, let's say a list, which we haven't learned about yet, it's going to return to me the number of entries or the number of values within that list. Okay, so it all depends on what type of object you send it, what type of result you're going to get back. So we did uppercase, lowercase is going to do basically the same thing. We did finds. Let's do slices. So we have this value in A, and if I only want a piece of it, I can do a slice operation. So let me do a 5, 7, 1. So what does this really mean? So 5 is the start point. So it's an index position within here. So we've got 0, 1, 2, 3, 4, 5. So I'm starting at I. I've got an endpoint, which is 7. So 5, 6, 7. So I'm stopping here. And then this is the step count. So 1 means I want every character, right? Now if I hit enter, notice I get IS, but I don't get IS space. Okay? The start is inclusive, so I definitely get what's at that start position. The stop is exclusive, so I'll get everything up to that stop position, but I don't actually get the stop. Okay, so I end up with IS. And because I specified 1, I get every character. Now again, not every one of these is required, so I can not include them. So if I take the starting position off, what I get is everything up to this endpoint. So I get this is right here. Now if I don't specify an endpoint, but I specify a start point, I will get everything from that start point all the way to the end because I didn't specify an ending. And if I don't specify either one, I get the entire string. Now 1 isn't required, I just get the original string. But if I put something other than 1 in there, notice here I get every other character. So every second character, so I got T, then 1, 2, I get I, then 1, 2, I get a space, 1, 2, I get an S, so on and so forth. Not immediately useful, but when you start thinking about I can perform slice operations on other objects like a list, it might become valuable to get every other item in that list. And it especially becomes useful with the neg1. So if I specify -1, what I end up with is I'm starting at the very beginning, but instead of going every character, I'm actually going backwards every character. And so what this does is reverses my string. So again, may not be immediately useful for a string, but is very useful when you're talking a list. And so we'll look at this a little bit more when we cover lists. So maybe I want to see from everything from the end to the beginning, right? So moving on, we'll talk a little bit about inputs. So how do I interact with, say, a user sitting on the console and have them pass something into my program? So we have this thing called input. So let me do a help on input. What we'll notice right away is input returns value. Well, that's odd. I expected to see string or integer or something like that. Value's pretty vague. And it's that way because, well, I'm going to pass in via raw input, and then I'm going to perform some type of evaluation on there. So Python's going to try to figure out, did the user enter a number? And if so, I'm going to store that into an integer. Well, if that number contains a decimal, well, then I'm going to evaluate it and say, well, it should be a float. Well, this type of evaluation has been found to be very insecure. People can really run amok with your program by using straight input. All right, so I would advise not using this. In Python 2.7, it's still in here. I would advise you to use raw input, and we'll look at that here in a second. In Python 3.5, they got rid of raw input, and they basically made input raw input. So whenever you put something in with the input command, it's going to give you a specific type back, not something vague like this. It's not going to perform this evaluation. Now notice here we also have prompt in here, and notice it's in square brackets, meaning it's optional. I would not leave it out, because then how is your user going to know what to type in? So I'll quit out of that. We'll do a help for raw input. And what we'll find here is that I'm going to get a string. There's no evaluation going on. It's just, it's going to be put in a string. And this is the functionality you really want. You want to perform your own kind of tests on what the user had put in, and not let Python try to figure it out. Because again, the user could put something in that's kind of malicious, and now your program's doing some funky stuff. All right, so let's quit from that. That's how our input is going to come in. So if we look, let's try something out. We'll do speed equals raw input, and inside of here I'll say give me a speed. And so it will prompt me, give me a speed. And so the user would enter something like 150. And now 150 is stored within speed, but it's stored as a string. All right, so if I do a type on speed, again, I'll see it's of type string. So pretty cool. That's how we're going to get input from our user. But then how do we send it back out as output? Well, I could do a couple things. I could do a concatenation. So if I do my car goes, well, how about I actually put quotes on that? My car goes plus speed plus MPH. What I get is my car goes 150 miles per hour. So the plus operator we saw when we did actual addition, now we're seeing that given a string, well, it just does a concatenation and concatenates them together. So we could do that inside of a print statement and print that to the standard output. Okay, so you get my car goes 150 miles per hour. Equally, there are other types of operators that we can use on it besides the plus operator. maybe for whatever reason I wanted 150 multiple times. So I can do speed times 10. So what I get is 150 10 times. Not readily useful in this kind of context, but maybe you were doing something like I wanted 100 A's. Now when people do penetration testing, oftentimes they'll use this kind of format because maybe I'm gonna keep sending you different sizes of a text and see at what point your program crashes, and then see what happens once it crashes, right? So this allows me to continue to manipulate the different sizes that I send it. So again, in this case, the plus sign did a concatenation. In this case, it took 10 of these and then concatenated them all together. Now, that's a little bit about concatenation, but we really wanted to get at our output. So we did a little bit of a print statement, right? We did this print, and that seems somewhat useful. I can take a string, concatenate it with another string, and get some kind of cool output. But what if I wanted to manipulate it a little bit further? Well, in that case, I'm not going to do concatenation at all. I want to do something like this, and I'm going to put these squirrely brackets in there. And after here, I'm going to do a dot format, and I'm going to put speed out here. And so in this way, I get the same exact result, but this time I'm doing a dot format afterwards instead of this concatenation here. Now this becomes useful when maybe you have a bunch of values you're trying to put in here, and so to close close with a quotation, remember to put your space in. You got plus signs on either side, and you're going to have to do this for every value or variable you're trying to put in. Instead, it's just easier to start putting squirrely brackets, dot format, and then list all your variables here at the end. So if you don't specify a number in here, it's going to default to whatever order you put it in. So if I had 5 different values in here and I didn't put them in, well, again, it just grabs them in the order that they're specified. Otherwise, I can also specify values. So I could have put a 0 in here, and 0 lines up with this first value. And then if I had other ones, I could put 1, 2, so on and so forth. But what I'm really trying to get at is maybe I want to display speed in another kind of way. I don't want 150 to be it. So maybe I'll convert this to a float. Let's see where that gets me. So now I've got 150.0 miles per hour. Maybe I want more than 1 decimal point. Well, here I can do a decimal, let's say 2. And what I end up with is some craziness. That's not at all what I expected to see. So how about I actually put an F in there to specify that I want it to output as a float. Okay, so now what I end up with is 150.00 because I wanted to see 2 decimal digits, right? And I could raise that if I really wanted to, so on and so forth. But let's say 2's good. But what I'm anticipating is that somebody's going to get a car that goes way faster than any other car in the history of mankind, right? So I want to specify that they can have more space within that sentence to put all of their digits. So here I'll put an 8, and that means I'm going to leave enough space for 8 total characters here, right? So I want to make sure that they have enough space to record something incredibly fast. Okay, so maybe car was a variable over here, And so now that they're going to specify a plane, I want to make sure, again, they have enough room, or maybe they have a rocket and it goes even faster. So rocket would show up here, and I need enough space in order to specify. So really, this is if you want to output and you're choosing some standardized formats and what have it. And so the way that it's displayed in columns needs to make sense, and so you'll spend some time making sure this all lines up. Maybe you want it centered within there. Maybe you want to make sure it's to the left. Maybe you want all your stuff to be left justified. So again, a lot of different control here on how it's displayed, and you don't even have to display it as integers formats. You could even, I know it doesn't make much sense to do it this way, but you can basically, can't do that right there. Again, you can specify as an integer and have extra space for it, or maybe it's not even about the integers. Maybe for whatever reason, you want it specified in hexadecimal. So 96 in hexadecimal actually lines up to 150 in decimal. Maybe for whatever reason you want it to output in binary. So now you've got it in binary. So again, doesn't make a whole lot of sense in this scenario, but you can see that there's a lot of power in the way that these are formatted. So I suggest, I've got the page open here, I suggest you kind of come through here and look. There's all sorts of different ways that you can format your output. You can display it in octal, you know, so on and so forth. There's, again, lots of different things that you can do. Specify percentage. You know, again, go to the docs for Python, look up format, and you'll find that there's all sorts of different things that you can do in here. And it really helps you to build some kind of standardized output, so that maybe things line up in columns and they all look pretty and everybody's happy and wonderful. So I, again, advise you give it a try. So before we close down, I want to cover just a couple other little things here. Text, let's say the value C, is represented in certain ways. So there's this thing called ORD, and ORD is going to return the ASCII value of C. So C to a computer isn't C at all, it's ASCII 99. And that's the way that a computer keeps track of the fact that this is a C, right? So there may be situations where you're manipulating text and you want to make sure that you don't go outside the bounds of certain character sets, and so you can track them by their ASCII value. And equally so, you can take an ASCII value and convert it back to its character equivalent. So if I did 110, I get the value n. So as you can see, you may end up using ORD, you may end up using char in order to manipulate your text, but ensure that it stays within the bounds of certain character sets. So that's pretty much it. That's what I wanted to cover. We kind of dug in, we did some concatenations, multiplications, but more importantly, what we found is because things are objects within Python, the string object comes with a lot of different things that we can manipulate, that we can really use to get at what we're trying to do. So again, it has all sorts of different methods, all the stuff that's kind of built in to make your life easier. So that's pretty much it. I hope you got something valuable out of that, and we'll be moving on with Python. Thanks for watching. Bye.